Welcome back, students. When it comes to chemistry of phenols, STT of phenols, qualitative tests for phenols, and Reimer-Tiemann reactions of phenols. These are the most important topics. So in this video, I'll be explaining about Reimer-Tiemann reactions of phenols, step-by-step mechanism involved in it in the easiest possible way. So stay with me till the end of this video because this is one of the important questions for your internal as well as external examinations. Now let's jump into the topic. Reaction. Whenever phenol is heated along with aqueous sodium hydroxide and chloroform, an aldehyde group will be generated and this group will be attached ortho to the phenolic hydroxyl group, and that is how there will be formation of salicylaldehyde as the major product in this reaction. So this reaction is known as Reimer-Tiemann reactions of phenols. Now let us consider its mechanism. So in the first step, chloroform reacts with aqueous alkali such as either sodium hydroxide or potassium hydroxide. So from these alkali, hydroxyl groups will be reacting with chloroform. Because hydroxyl ions are basic in nature, they will try to always abstract protons. So they will abstract proton, that is hydrogen, from the chloroform. And that is how they will be making water. So OH minus, it reacts with H plus, and thus there will be formation of water molecule as one of the product. Now in this reaction, when deprotonation occurs, that is when hydrogen is removed from chloroform, so the molecule will be retained with CCl3 unit. Because hydrogen is lost in the form of proton, the electron pair which is shared with carbon will be retained along with carbon. So that is how there will be formation of CCl3. Because it is having excess pair of electrons, it bears negative charge. Now the formed anion CCl3 minus ion, it dissociates into chloride ion and CCl2. So this CCl2 is known as dichlorocarbene, which acts as electrophilic reagent in this particular reaction. Dichlorocarbene consists of an electron deficient carbon. There will be two pairs of electrons from CCl bonds which are present in dichlorocarbene and a pair of electrons which are coming from the deprotonation in the first step. Okay, so overall if you look at the electronic configuration, there are only 6 sets of electrons are available around the carbon. And it is lacking a pair of electrons to meet with the octet configuration. As you are aware, octet configuration is stable configuration. Thus, the carbon in dichlorocarbene is considered to be electron deficient, and it is because of that reason dichlorocarbene is considered as electrophile. As phenols usually undergo aromatic electrophilic substitution reactions, the formed dichlorocarbene acts as electrophile and it attacks onto the phenol ring system on the ortho position in the next step. Because phenolic hydroxyl group is orthopara directing group. By the action of phenol with aqueous sodium hydroxide, there will be formation of phenoxide. So the formed dichlorocarbene reacts with phenoxide ion. When dichlorocarbene attacks on aromatic ring system, because hydroxyl group is an activating group and also it is an orthopara directing group, this dichlorocarbene attacks on the ortho position on this aromatic ring system. So while attacking dichlorocarbene, it utilizes one of the pi bond which is available at the ortho position. By utilizing this pair of electrons, CCl2 group will make a bond with the aromatic carbon. Because it is getting excess pair of electrons from the aromatic ring system, there will be generation of negative charge on the CCl2 group. When we transfer this pi bond, there will be deficient of electrons at first position. To compensate that, the electrons which are present on the phenoxide ion will be transferred. So that is how there will be formation of a double bond in the intermediate. Now in the next step, proton transfer occurs because CCl2 group is bearing negative charge and in the surrounding there is availability of protons. So these protons will be lost from the second position and they will be immediately taken up by the carbon of the CCl2 group, and that is how there will be formation of CHCl2 group ortho to that of the phenolic hydroxyl group on the benzene ring system. While deprotonation, this bonded pair of electrons will be again transferred in the form of double bond. That is how the aromatic ring system gets back its third pi bond. In that case, the first carbon becomes pentavalent. To compensate that, the doubly bonded electrons are again transferred back onto the oxygen in the form of negative charge. That means here the bond between carbon and hydrogen will be transferred in the form of double bond. As soon as double bond is formed at this particular position, immediately the doubly bonded electrons will move onto the oxygen in the form of lone pair of electrons, and thus again oxygen gets back negative charge. And that is how there will be formation of a transition state intermediate. So this intermediate is highly unstable, and that is the reason immediately CHCl2 group will be converted to an aldehyde group in the immediate step. Now when this ultimate intermediate is subjected for mineral acids such as hydrochloric acid or sulfuric acid, immediately protons will be taken up by the phenoxide group and thus there will be formation of salicylaldehyde as the product. So this is how upon reaction of phenols with chloroform in the presence of aqueous alkali, the aldehyde group will be transferred onto the ortho position on the phenolic ring system. And that is how finally we get salicylaldehyde as the product. So this reaction is known as Reimer-Tiemann reactions of phenols. Reimer-Tiemann reaction is not only characteristic for phenolic compounds but also for the heterocyclic compounds. Now that you have learned about Reimer-Tiemann reaction, here is a quick challenge for you. Two molecules are displayed on the screen. So give the products of Reimer-Tiemann reactions of these two compounds in the comments. If this video is useful to you, then give it a like, subscribe my channel so that you won't miss my next coming chemistry concepts. I'll catch you in my next video with another important topic, that is qualitative test for phenols. Thanks for watching and stay tuned to my next video.